Okay, so today we're looking at definite integrals. Remember we looked yesterday, I told you integrals has two meanings. Right? One is a summation of numbers and then the other one is inverse of a differentiation. Yesterday we looked at differentiation, the inverse of differentiation. Today we're looking at the other part. So I'm on page 256. So you remember like how we had limits for differentiation? Okay, you get something similar to limits but for integrals, right? So they give you this. Right? So this is known as your upper limit, right? And this is known as your lower limit. Now if you derive if you integrate a derivative, you end up with a. If you integrate a derivative, you'll end up with a. If I integrate f prime x, I'll end up with.
You should go back to original.
So what will that be? If I'm integrating this, f prime x, which is a derivative, I'll end up with. See, right? This is a function, right?
Yeah.
If I derive this function, I end up with f prime x. If I integrate the derivative, I'm going to end up with the function. Understand? But remember, it's the inverse of differentiation. So if differentiation took place this way, and when you integrate, it's the inverse of differentiating. I'm getting it back into the original equation. Okay? So I'm given this. I'm given the integral of f prime x with the upper limit of b and the lower limit of a. So when you integrate it, you're going to end up with f of x. But now you have these limits. How do you use these limits? Right? So when you integrate it, you'll write it with still showing these limits. And how do you use these limits? You'll say upper limit minus lower limit. Okay? And when you're substituting it, it's going to be f of b minus f of a. You're going to see it in the examples, right? But this is definite integrals, and we use this when we're working on areas under a graph. Okay? So this is basically, you have an upper limit and lower limit of a derivative. You're integrating the derivative, you're going to end up with a function. You substitute your values for your upper and lower limits, and you always subtract your upper limit from your lower limit. You okay with that? Okay. So let's look at page 257. We're looking at page 257 and 256 at the same time. Okay. So on page 256, they got a graph. Okay. They got this graph, and this graph has this line where y is equal to x. That's your graph, right? Fine. So they tell you consider a very narrow rectangle of length y and breadth dx. So it's a very, very narrow rectangle. So it has a length of y and a breadth of dx, the value with respect to x. Okay? Remember that dx is very small and it tends to move towards 0. It's a very small value. Couldn't write any smaller, you won't see it, right? But it's a very small value. Okay? So the area of this rectangle, you with me? Area of this rectangle is with, so when you write with respect to the area, it's going to be equal to the length times the breadth of the rectangle. I wrote bread. How you spell that? Oh, it's right.
Yeah.
Right. the area of this rectangle because it's a rectangle, right? It's going to be the length times the breadth. Yes?
Yeah.
That's 2. Right? So, your length is y and your breadth is dx. Okay? So far, all right?
Yeah.
Now, if we integrate both sides, okay, so you're going to end up with dA equal to y dx, right? If you integrate both sides, remember the integral of this would be a. Because it's integral of d of a, right? Like the derivative of a. Okay? So you're going to end up with a equal to the integral of y with respect to x. Still all together, right? But how can you integrate y to make it with respect to x? Because how are you going to get y to x? If you just integrate y, there's no x in that associated equation here, right? But from your graph, what do you know? That y is equal to x. So, area would be equal to the integral of x dx. So far you're with me, right? So what we basically just made is a general formula for working on an area at any points under this curve, provided that you have an upper limit and a lower limit. And you're going to see what I mean by that, right? Because you see for their one, they used 3 and 1, right? So they use an upper limit of 3, a lower limit of 1, right? So say 1 is here. And say 3 is okay? That's your upper limit, that's your lower limit. Now you want to work out the area of that. So what would you do? Remember I told you you would take your upper limit minus your lower limit. But what's the first thing you need to do? You need to integrate this. Okay? So if you integrate this, you have what? Integral of x. Integral of x. Okay, you guys so far before I carry on? So you'll understand what I did so far up until there. Up until, okay, you understand this?
Yes.
You understand this? You understand this?
Yes.
You understand this?
Yes.
You understand the addition of this upper and lower limits? Okay? You understand this? So now I want to integrate x to the power 1 over
X.
2. Right? X to the power n plus 1 over n plus 1. Yesterday we all came class.
No, we tell her that you little.
Okay, so it's x to the power 2 all over 2 plus a constant, and you have an upper limit of 3, lower limit of 1. Right? And remember what I told you? When you're using your upper and lower limits, it's your upper limit minus your lower limit. Okay? All still with me? So, how you would write this out, you would say 3 squared over 2 plus c minus 1 squared over 2 plus c. That's the upper limit because you substitute. Remember like how I wrote over here? F of b, the value of b into that function, minus the value of a into that function. Okay? Right. So you're going to end up here with 9 over 2 plus c minus half minus c.
I'm not following.
Which one?
So the 3 squared over 2 plus c.
Mm-hmm.
Oh, okay.
That's the upper,
Okay.
and then it's the same like how this
Following,
is.
sorry.
F of b, so you substitute
Okay, so you substitute the top limit and then you set the bottom limit.
the bottom
Okay.
into this
Sine
equation.
Okay.
Okay? Then you're going to end up with 8 over 2, because remember this and this would cancel, and that's 4. That's what we did, right? What we basically did was we worked out the area under the curve from 1 to 3. Okay? And if you read there, they tell you that if the top limit of 3 is substituted, you obtain area OBC. So you see from where that 0 point is on your graph till B, where B is where 3 is, right? Up until C. You basically worked out the area of that triangle. Okay? And then if you look at, if the bottom limit of 1 is substituted, you're working out OAD. Right? And if you subtract that OBC minus OAD, you're left with an inside portion between 1 and 3. Do you all agree? Because remember, this here is OBC, and this is OAD. So what they're telling you, when you substituted this upper limit of 3, right? And you worked out this portion, this first portion only, right? You basically worked out OBC, the big triangle, right? And then when you substituted 1, you worked out the small triangle. And what we did, we subtracted the big triangle from the small triangle. So we were left with this, which is the area between 1 and 3. That's what we did. We worked out the area under the curve. So when you're writing your answers, right, very important that you all draw this strip first. Because the strip is basically going to get you to this part. Where you say D of the area is equal to length times breadth. The length we established is Y because it goes up Y amount of units. And we always say that it's multiplied by a breadth of a very small value of x. We call it dx, right? And we say it's approaching 0 from the theory it gave. So to work out the area of that rectangle, it will be length times breadth. With me? Okay, so I ended up with dA equal to y dx. You introduce your integral sign on both sides. And if you integrate that dA, you end up with a. Now we're integrating y with respect to dx. But y is its own function, it's not x. But we know that y is equal to an equation that has x, which was this. So we substituted it there, and then we integrated x dx, and we got x squared over 2 plus c. They want you to work out between 1 and 3. So you substitute your limits, your upper and lower limits, and you get your answer. So that there, in terms of, it would have been units squared. Okay, because area is squared. When we don't deal with meters and millimeters and stuff, we call it units in maths.
Yeah, because
It could be anything, right?
the answers of the.
Do you understand what I did here?
Yeah.
Anybody confused? Right? It's something new to take in. You will get it because we're going to do a bit more examples. But for the starting basis, you need to understand this. Do you understand this? Yeah. Okay. Take it down, take a picture. You'll see we'll do more of this in the past year paper questions because the textbook doesn't really do much of that. But your integration questions will be broken up between that first part we did using the short rules and then this part here. Tuesday. That's a 10. Next week, this time you'll be writing, yeah? There'll be 20 minutes into the maths exam. Probably writing the same numbers too.
Yeah. Then you'll know whether it's done.
I don't see how it is.
We'll see our faces after
That's
I don't see how it
When I collect your paper, I'll look at it.
is.
You know, make sure I look at it before I put it in the packet and send it to the department. No, but I can't. Because I'm the lecturer of the thing I have to.
I find it like.
But then would you even see the test paper?
It's only every year.
No, you did the other people change.
Oh, okay.
But we'll come start the exam, read the rules, do everything. Give you a pep talk. Early's gonna pray fast before we start the paper.
Thanks for volunteering.
I don't think that's a good idea.
Okay, who's the most religious from all of us here?
Cindy.
Cindy, you're gonna pray fast before we start the paper, right?
Thanks, Sandy.
Before each paper, at 8:30. Cindy's gonna pray. We're gonna start. Do this.
Yeah. But please, like,
Yeah.
no formulas and stuff that you will confuse.
Please.
Yeah, please, no. Not allowed to use certain words.
Maybe we started at the start. Yeah, I never started at the start. The textbook starts at the start.
No, we are not in
Okay, the textbook starts a couple of pages in with good. Like my science textbook, I can say, hey, it starts at that thing.
No, we
First
never.
page. What you mean?
No, we never.
section.
No, we never.
In science?
Ah.
What? What we started with the other textbook, then we entered this one. No, I'm saying with this textbook, but we started.
You started with that textbook, we were like, hey, no. This textbook, no.
Yeah.
Give us a new one. You want a new textbook.
Right, guys?
Yeah.
Okay.
Yes, I'm just doing questions.
You got the tip? Done. I had someone tell me. Got the tip. But I needed to mark fast because I need to give it tomorrow. Okay, I'm going to do some examples now of how you would use upper and lower limits before I go into questions where I'm going to do areas with it, right? So let's get used to using this upper and lower limits. So, say for example you have, where am I looking? 4 and 2. Upper limit of 4, lower limit of 2.
3x squared dx.
Dx, right? This is what they gave you. The upper limit of 4, lower limit of 2, 3x squared dx, simplified, right? So, first thing you would do, you would need to integrate this, okay? What you do first, you put your constant terms. Integrating from 2 to 4, x squared dx, right? Integral of this,
X over 2.
3x.
Yeah.
and then you must start getting used to writing it like this, where you have your upper and lower limits, right? So you don't forget that there is an upper and lower limit. Plus C, sorry.
Forgot about it. Well, you said classes today.
So this is gonna cancel, right? You're gonna end up with x cubed plus c, and you're integrating from 4 to 2, right? Now when you're using your upper and lower limits, you substitute it. You substitute your upper first minus your lower limit, right? So this is 3. No, this is 4. He wasn't in the class yesterday. Plus c minus 2 cubed plus c. Right? Upper limit minus your lower limit where it substitutes into the function. 4 cubed.
Yeah.
64 plus c minus 8 minus c, right? Cancel, cancel. 64 minus 8, 56. So that's your answer.
We always have a situation where
So,
C minus
right, your c values will always cancel when you are doing definite integrals because you're subtracting your upper and your lower limits. Okay? Let's do another example. Right? They tell you 0 to 2. Okay, the integral 0 to 2 e to the 3x dx. So how would you do this? You're going to integrate the e to the 3x. Right? If you integrate e to the 3x, what you end up with? It's e to the power kx, which is that's e to the x. E to the kx is
same rules.
e to the 3x over 3. It's e to the power kx over k. Right? Plus c from 0 to 2. So now you're going to substitute. I'm going to say e to the 3 times 2 over 3 plus c minus e to the 3 times 0 over 3 plus c. What you get here? One three 4.476 minus e to the power 0 over 3. Means 0.33, 1.33, no 0.33. Right, it's going to be plus c minus 0.333 minus c, right? Cancel, cancel, you're left with 134.143. That's your answer. Understand it? Okay. Then let's do another one. Okay, let's do integrating from 0 to pi over 4 cos x dx. Right? Integral of cos x is sin x plus c. Integrating from 0 to pi over 4. So now what you do? Substitute your upper and lower limits. So it will be sin of pi over 4 plus c minus sin of 0 plus c. Now, the thing with these questions with integrals and when you're working with pi, the calculator must be in radians. Okay? So, swatch ender. Right?
0.7
0.707 plus C minus 0 minus C. Cancel, cancel, you're left with 0.707. Yeah? Okay, so you're understanding how we use upper and lower limits, right? Okay, good. So close to the end. You can smell it. Can I understand you good?
Yes.
Yeah, is that? Right, now I'm on page 259. Okay, calculations of areas using integration. So it's going to be similar to how I, on the start of the lesson, it's going to be something similar to that, right? Okay, so they tell you calculate the area between y is equal to 2x plus 1, the x-axis and then they give you 5 different points where you must work it out, okay? Between these two values, like x between 0 and 2, between minus half and 0, minus half and 2, then the whole thing there. So, how do you do this? The first thing you need to do is sketch the graph first. Okay, so they're giving you y is equal to 2x plus 1. Looking at this, what type of graph is it? Straight line graph. Okay, now this is also you need to remember your graph formulas and how you would draw it and stuff. Okay, all that comes into play, right? So for your y-intercept, you let x equal to 0, so you'll say y is equal to 2 times 0 plus 1, y is equal to 1. So its coordinate is 0 and 1. Your x-intercept, you let y equal to 0, so you end up with 0 equal to 2x plus 1. X is equal to minus half, right? So you have minus half and 0. So if you were to draw the graph, this point here is 0 and 1, and then say somewhere here is half, right? So your graph would look like, I must that down completely. Okay, so this is y is equal to 2x plus 1. Bear with me. Okay. Then what you're going to do, you're going to need to do your element rectangle. So you know in the start that strip we drew, that's your element rectangle. Okay, so the first thing you're going to do, you're going to say anywhere you want, somewhere over here, you'll say draw a rectangle. What would be its length? Y, right? It's going up by y amount of units, okay? And then remember we always say a narrow x, okay? So dx is moving towards 0. So now you're going to start asking it, okay? So, question 1, they want it between 0 and x equal to 2. So the first thing we need to do is come up with a general formula for the area, like how we did for the first question. Okay, so remember dA would be equal to length times breadth. Everybody's with me? dA is equal to your length is y, your breadth is dx. So dA is equal to y dx. Then you're going to introduce your integrals on both sides. When you do that, you're going to end up with a equal to the integral of y dx. But how can we integrate y to get you to x? You need to substitute the equation for y. So this would be the integral of 2x plus 1. For the question, what was your upper and lower limits?
0 and 2.
So which would be your upper, which would be your lower?
2 is
Okay, so how this works is you basically identify from the left to the right. So for whatever number they give you on the left, that will be your lower limit. Whichever number is on your right, that will be your upper limit. So they want us to look at 0 and
2.
say 2 is there, right? Right? So they want us, so our lower limit will be 0, upper limit will be 2. So lower limit is 0, upper limit is 2. So, okay, so up until this point here, everybody's still with me.
Yeah.
Sure. Right. So now this is like how we did our upper and lower limit questions, right? So what you do here? Integrate first, then integrate first. So this will become what? So it's going to be 2x squared over 2 plus
C plus 1.
Yeah.
integral of 1. Yeah, no, but now we've passed that point. We know that you're doing both
Yeah.
separately, right? So what's the integral of 1? Integral of 1?
Median plus.
Yesterday we had class, no?
Yeah.
Feels like we had class last week, right? So this is 2 times x to the power 1 plus 1 all over 1 plus 1
Yeah.
plus x to the power 0 plus 1 all over. Remember 1 is x to the power. We did examples like that yesterday.
Yeah, but then we did, yeah. No, we did, but that's.
Just kidding. Just say yourself.
No, I'm just trying to figure out. That means that we're introducing x in a way.
Yesterday you were here.
Yeah.
Yesterday we did this. This is the same thing as integrating dx. Remember, if I did it separately, I would have said integral of 2x in plus the integral of 1 dx, which is integral of dx.
Okay.
Right? Because remember, this is not derivative. Now, if you got the constant here, you're going to get a value.
Okay.
Right? Okay? This is not derivative, but you are remembering derivatives too much. Right? So, this will be plus c and your limits of 2 and 0. So this is 2 times x squared over 2 plus x plus c. Cancel, cancel. You're left with x squared plus x plus c with limits of 0 to 2. Understand?
Yeah.
So what you do now? Substitute. Right? So you substitute your upper limit first, which is 2 squared plus 2 plus c, minus your lower limit, which is 0 squared plus 0 plus c. So you're going to end up with 4 plus 2 plus c minus 0, 0 minus c. Cancel, cancel. You're left with 6 units squared. Okay. Wait, I can take it at just time. Let me do everything one time and then. Okay, so before I carry on, everybody understands this part, right? How we answer the question, you start firstly by drawing the graph, whatever graph they gave you. Okay, so in this instance, we got a straight line, we just needed to know the intercepts. So you drew your graph, right? Drew your graph, you draw your rectangle, because that rectangle basically explains how you're getting this part here. Okay, so you drew your rectangle, dA is equal to your length times your breadth. dA is equal to y times dx because your length is y, your breadth is dx. Right? When you introduce your integral sign, you basically you're sort of integrating dA with respect to a, so you end up with a equal to the integral of y dx. So now we need to integrate equation y with respect to x. And the only way to do that is to substitute the equation for y because that has x variables. Right? That's how I ended up with 2x plus 1 dx. Then I integrated 2x plus 1. And this is integration rules. And then I came up with this. And remember, we have limits of 0 to 2. And how you use those limits, you substitute your upper limit minus your lower limit, and you come out to a value. Remember, your c will always cancel. So what that basically means, the area from 0 to 2 in this whole part is 6 units squared. Do we understand that? Yes. Is anybody confused? Okay. For number 2, they want it between which value?
Minus a half and 0.
Minus a half and 0. Okay? So what they want you to integrate is this is minus a half, right? And this is 0. So they want you to integrate that small triangle. You see?
Yeah.
That small triangle. That's the area they want you to work out. How you would do this? You basically already established the general formula for this now to work out area for the specific graph. Right? You've established that A is equal to the integral of 2x plus 1 dx. And now your limits would be, you start from left to right. Left is your lower, the right value is your upper. So this is minus a half to 0. Still with me?
Okay.
That. From what we did here, we have established that when you integrate this, you're going to end up with x squared plus x plus c, integrating from minus half to 0. So what you're going to do, you're going to substitute. So this is going to come 0 squared plus 0 plus c minus a half squared plus, okay, plus minus half plus c. You know this is going to come to only c, right? Minus a half squared is what? Quarter. Quarter, right? And then with the negative sign, it's going to be minus quarter. Okay, minus half squared is a quarter times this minus sign is, and then you're going to end up with plus a half minus c. Cancel, cancel. A quarter minus half is quarter. Okay, so this is a quarter units squared. So now the area of this is 0.25 units squared. Are you okay with that?
Yes.
Okay, so I'm just going to write half here. Minus a half. Same method like how we did that, but because we have already established the general formula, you don't have to keep on repeating it. Okay? Then they ask you for minus half and 2. So they want to know from here, from this point here to there, what is the area? Right? You can do it one of two ways. We can do it exactly like how we did this, where we said that area is equal to the integral of 2x plus 1 dx, and we're integrating from minus a half to 2. Okay? We've established that that's your formula. You get x squared plus x plus c, integrating from minus half to 2. So we know this is going to be 2 squared plus 2 plus c minus half squared plus minus half plus c. Right? We know that this here is going to come out to 6 plus c. I must write it separately. 2 squared is 4 plus 2 is 6. Right? Here we've set it over here, it comes out to minus a quarter plus half minus what?
Isn't that a minus half?
Here,
No, I mean, it's the
The
minus
minus
half.
sign is outside the bracket.
here.
That times the negative.
Oh.
That positive times.
Because remember here, minus half squared is quarter, then you end up with minus quarter. Minus times minus half,
Okay.
positive half. Okay? Then, that was here. Okay? Cancel, cancel. What's this? 6 minus a quarter is?
5 and 3 quarters.
Oh, 6 plus a quarter is 6 and a quarter, which is?
5 and, no, it's 5 and 3 quarters.
Yes, minus half. See the negative sign? When you multiply it into the bracket, you can end up with?
No, the thing is, we're not seeing that it's again, that's why, that's how it's going. Yeah, you don't realize we're multiplying it from outside. No, it's fine, it's outside. I'm saying we're not, you get here, that's fine.
Yeah, I'm here for the here.
Oh,
I don't know what the number is.
5 and 3 quarters plus a half is 6,
from your bank.
6.25.
Okay, let's just say 6,25, right?
Yeah.
6,25
2.5.
units squared.
It's 5.5.
Sorry, that's it. You have to look at
To
it.
see.
I'm gonna write this as 0.25, right?
Oh, this is not
Okay. So please tell me if you don't understand. Please tell me, right? You'll understand what we did in question 3, right? Okay.
Same thing you did it too.
Same thing we did in 2, same thing we did in 1, right? But the more I do it, obviously you're gonna get it. But obviously I'm not doing this for nothing. I'm doing it for these, right? So Remember in question 1 we worked it from 0 to 2 area, right? Question 2 I worked out the area from minus half to 0. This was 0.25, agree? This area was 6. If I added this area to each other, what I get? And when I integrate it from minus half to 2, what I get?
6.25.
Right? 2 ways in which you could have worked it out. Could have just added the 2. Or you could have said at the start, you could have said over there, instead of integrating from there, you could have said, you could have, for this one, right? You could have said, see over there we had, the area would have been equal to your integral from minus half to 0, right? Of 2x plus 1 dx plus from 0 to 2, right? 2x
But
plus 1
so then let's just like repeating
dx,
Yeah.
right? We worked out the value, we know that this here is 0.25 plus 6, which is
Okay.
right? Because you did work it out, but why I'm doing this, I'm doing it for this reason because you're gonna come to a point, right? I never draw this line here for nothing in the bottom. Because you're gonna see on the next one, they're gonna ask you to work out from minus half to I think minus 2. From minus 2 to minus half. Right? So you're gonna work out this part as well. Then you're gonna come to a point where they're gonna tell you work out from minus half to 2. Right? And then you're gonna see what's gonna happen because this is area that's below the x-axis. And this is area that's above the x-axis. So here you're gonna come out with positive values. Because remember, your upper limit is greater than your lower limit. Okay, so you're gonna come here. Remember the values, what's gonna happen? You got negatives in both. You're gonna see it now, right? So for now, take this down and then let me. Can you please don't break your phone? Okay. Yeah, can you check out the photo and then I can.
But then for area, I mean, you can't have negative values for area.
That's the thing. That's what I'm coming to. Are you gonna take the absolute value of it,
Okay.
and then you take it as a positive?
This thing is not the method is not difficult. It's just
Then
it's the detail.
checking out the
You
set.
get all the details right. Can be tricky.
That's the thing. But the more you practice it, it's not difficult. Because even integration rules are not difficult. Then
Yeah.
number four, they ask you to do it from minus 2 and minus half. So we've established the area formula in terms of working on area for this graph is integrating from your lower to your upper limit for 2x plus 1 dx, right? So this is 2x plus 1 dx. They want us to integrate from minus half to from minus 2. So in terms of the graph, it will look somewhere. So that's 1. Say that's 2, right? So they want you to integrate this triangle now. Right? That's what we're integrating. Okay? So we've established that when you integrate this formula, you end up with x squared plus x plus c, and your lower limit is minus 2, upper limit is minus half. All with me, right? Because remember, you write it from left to right. Your left value is your lower limit, your right value is your upper limit. Okay. Now you're going to substitute. You're going to end up with minus a half squared plus minus half plus c minus 2 squared minus 2 plus c, right? Minus a half squared is a quarter, positive quarter, right? Minus half plus c minus 2 squared is, and the minus sign multiplied into it will be, must I write this part first and then do the minus sign part? Do it like how many?
Oh, yeah.
110. Okay, so this would be minus 4. Minus 2 times minus is plus 2 minus c. All with me so far.
Yes.
So cancel, cancel. Put this in your calculator, tell me what you get. Okay, don't put it in your calculator. Quarter and minus half is minus quarter. Right? Minus 4 and 2 is minus 2. So minus 2 minus a quarter is
1 and 3 quarters.
minus, it's 2.25. Can you get a negative area? No such thing as negative area, right? So what you do is you take the absolute value of it. The absolute value means that even if it's a negative number, you take it as a positive number. Okay? So what they normally do, it looks like how your determinants line looks. So you take your absolute value, which is 2.25 units. See, remember the units, no? Okay, because you can't get a negative area. Negative area, I don't know what it means. Because area is like a space. Like this is the area, right? But because these values fall below the x-axis, you're gonna get a negative value. And how you do this, you have to visually look at this. You have to look and see, okay, this portion here from negative 2 to negative half is below the x-axis. So we're gonna get a negative value. So when you're doing your calculations, you do it with absolute brackets around this whole thing, and I'm gonna show you on the next one. I just did it like this now, so you understand the concept, but you understand the concept?
Yes.
Okay. Then for the next one, they want between minus 2 and 2. They want to know from here to here, what is the area? They want to know the whole thing here and the whole thing here, right? So one of two ways of doing it, right? You could have said that the area of it would just be 6.25 plus 2.25, right? And this is 8.5. But that's because we worked out these values. Okay? Now what happens if you are to do it, if this was the start of the calculation, okay? You drew your graph and they told you calculate the area from minus 2 and 2. X is equal to minus 2 and 2, exactly like how the question is, without that calculation. Okay? Now remember, your graph goes like this to here, it breaks, then it goes positive. Okay? So this is how we're going to do it. We're going to integrate from minus 2 to minus half, plus minus half to 2. But in terms of this, the area you get is going to be what? So this is how you write it, okay? So you'll say area is equal to the absolute value of, when you're integrating, of minus 2 to minus half 2x plus 1 dx, right? I know it looks like determinants, like how the determinants, but plus minus half to 2 to x plus 1 dx. Okay?
Those two lines are for the absolutes.
Absolute. I want to take the absolute value of whatever number obtained. Okay? And we gathered that because we see that below the x-axis we know the area is going to be negative. Everybody understand what I'm doing? So this here will become the absolute value of x squared plus x plus c from minus 2 to minus half plus x squared plus x plus c from minus half to 2, right? So remember, okay, we did the substitution here, right? So, Master, show it. It's fine, right?
Yeah.
Right? So here you would have ended up with 2.25 plus 6.25. You would have done this part here, and you would have done this part here, right? And then you end up with 8.5 units squared. Okay.
So that means if there's a break between, then you don't just do it as one.
You can't just go
You
straight
have to do it
from
separately.
there to there because
Okay.
it's not really the break between, it's where you can see how the triangles flip. It's like two different
It's two
triangles.
separate.
So like we're basically integrating from here to here to solve for that area, and then we're integrating from there to solve for that one. Why we didn't change the way our formula look is because it's still the same line formula.
Yeah.
Okay, so guys, do we understand this?
Yeah.
This is basically like the last part of integration that you need to know. It's not the worst thing in the world.
Yeah.
It's not the worst.
We see the taxes.
Yeah.
That's I think will be.
This example was very nice because what they did was they started from each portion. You see, when we started the question in question 1, we did it from 0 to 2. Then we did the smallest triangle from -half to 0. Then we did from -half to -2.
Yeah.
And then I showed you for the whole thing. So in an exam question, they'll probably ask you like question 5, right? They'll tell you exactly like how this question says. Calculate the area between y is equal to 2x plus 1, the x-axis and they'll say x is equal to -2 and 2. So how are you going to start your question? You're going to draw your graph first. Okay? You're going to establish where -2 and 2 is because that's your limits between where you're going. Okay? Once you do that, you are able to identify what triangles you're looking at. You draw that strip and you basically derive your formula like how we did in, or you integrate to get your formula like how we did in question 1. Then you just substitute your limits. When we're doing past year papers, we'll see a bit more of this. We'll do more of this. Right?
Yes. It's 15 marks.
No, 25.
25. They give you a lot of. But also last semester's paper, they split it 2020. SIG was 20, and then I think graphs was also 20, and then they put complex and determinants together. So if you do that year 2, it's actually okay because you're good at graphs. But you're good at everything. Eh? Okay, on page, so the calculation took us from page 260 to 261, right? Please don't forget the absolute value thing. Very important, right? If you see below the curve and you know an area is going to be 0, area is going to be negative, you take the absolute value of it, okay? The example on 261 is not prescribed by the syllabus, so we're not going to do that one. That one there is when they do it in terms of y, when they tell you calculate it in terms of y. Same method, you can practice it when you get a chance. That you'll understand, but no need for us to do it, okay? So that brings me on to page 264. But you can take this down first because nobody is listening to me. And then we'll do
I took a photo, you can have your
okay. 264. Because you know these people love to add sig into a situation.
Hey, trick is everywhere.
How is asking about this? It's almost done. I think we're all the way. all the way next door.
Yeah, I feel everything. So, yeah.
Started this course on the 28th of May. And then this week Friday is the 28th of July. 4 months, so fast.
Hey, very fast.
Yes. And everybody's still sat in the same place they sat in the first day.
You like
That's
it?
in this place.
No, it's
Somebody is always here.
Tell me it's always there.
Temba is always there. Bilal used to find one spot, but then now you got used to that spot because
You like routine.
Yeah, so you know.
Kaya sat next to Siabonga in the back there.
See, I finished.
Change to friend.
Then Mtokozisi and Temba used to sit next to each other.
Yeah.
See, I wish you had pants.
Yeah.
Very nice food. Very nice food.
He's just flowing.
So, the next trimester starts again in September sometime, huh?
Say second week. It's
Second week.
third week.
So we expect to get our marks.
Hopefully by the second week. So whenever the semester starts, the week before you should get your marks. Because the exams only finish on the
14.
no, yours exams finish on the actual exam. I think it's like 28 because it's normally a month.
Okay.
So from 28 to 28. But they'll be marking all your stuff as they go. But they'll only release once everything is marked.
So you only know if you're going to do the second level.
Oh, you? Yeah.
Like
But
a week
no, if you,
before.
yeah. But you're planning that you're going to do it.
Yes.
Because you're going to get A's in the papers.
And you're going to throw us a party.
And then, when you get your N4 certificate,
Right.
we're going to, I'm going to go for a haircut because I never had time to go for a haircut in these last 2 months.
So,
Because I must go home and prep already.
so this party is an open bar? Or?
Yeah, you're provided.
Oh.
Because apparently, I don't know, Sulisha, I heard that the separate people, they party bigger. They party very big. We don't know about it, but
Engine.
I think the only way to prove the point is to show us.
We had a
Because
clubhouse.
separate people can party.
So we
Just
want
like
to see
we
that.
don't work at separate
Engine, Pegasus club. We also, there's
Very nice.
yeah.
We have nothing. We're done with science today, sir.
Nice. Now I can just
I was done after this.
read more.
Last video you posted. No, but I'll video the last video.
I can do that.
How did you do it? Tomorrow we'll be looking at last semester's papers.
I'm going to change the structure of our times for this week.
We are changing.
And also, we also need to do work on our own.
True. I have a 10 minute. But I think Avi needs to also finish some stuff with it. So.
Just now the whole book.
Easier said than done. You got it there?
Yeah.
Yes. I do the same thing. Separate party. He must invite us for a separate party. Okay. I'm doing the example that's on page 264. They want you to calculate the area between y is equal to cos 2x, the x-axis, and between points of x is equal to 0 and x is equal to pi over 2. Right? That's what you have to do.
Okay.
So, first thing we would do, what we do?
Let's try 86.
Draw the graph, right? Let's draw the graph. So, for your y-intercept, let x equal to 0. So, y is equal to cos of 2 times 0, which is cos of 0. So, y is equal to 1. Okay, you're going to print your calculator.
Yeah.
Remember the graph, the cos graph starts at the top, right? So, cos of 0 is 10. So, one coordinate is 0 and 1. Then your x-intercept, you let y equal to 0. So, you have 0 is equal to cos 2x. See? What's 0? When you have cos of something equal to 0, what would you do?
0 points.
0 points, right? You have 0 points for this instance. Before we carry on, remember your limits is between 0 and pi over 2. What's pi over 2? What's pi? Pi is 180, right? 180 over 2 is 90 degrees. So you're only drawing from 0 to 90 degrees. So whatever values of x you work out here should lie between 0 and 90 degrees. So for your first 0 point, 2x is equal to 90 degrees. Remember, we take the inside portion, we let it equal to your first 0 point. Cos 0 points are 90, 270, 450, 630, so on. Sin 0 points are 0, 180, 360, so on. Right? So x is equal to 45 degrees. Falls in our limit. Cool. Right? Other one, 2x is equal to 270. X is equal to 135. Doesn't fall in our limit. So now we know our x values. So what we can do? Draw our graph. Right? Remember, your amplitude here is 1. Right? So your upper limit here will be, your upper amplitude will be 1, and this would be anybody confused with that picture? Okay, you're drawing from 0 to say pi over 2. Right? Your 0 point is 45 degrees. That's pi over 4. 180 divided by 4 is 45 degrees. Okay? So, say it here. Okay? So we're drawing until there. Remember, a cos graph starts from here and then you move. Our next 0 point is at 135. So when you draw this graph, it's not coming to 0 here. Remember, it would have been to 0 at 135, not here. So when you're drawing this, nope, you don't draw it again. You curve it better. Then just leave it like that. Right? That's a curve. And it doesn't look like a curve, but it's a curve. Okay? Better looking diagram is the one they're drawing. Okay. Now that we have that, so far you okay, understand that?
So we put the x point for 45 And the 135?
Remember, we don't have to draw it because our limits is only between 0 and 90 degrees, right? Pi over 2 is 90, right?
Oh, that's what we do.
Okay, so this here is y is equal to cos 2x. So now that we have this, got our graph, what do you do next? Yeah, that rectangular strip, right? So we draw it here. And it will be a height of y or a length of y and a breadth of dx. So now looking at this, right? We know that pi over 2 is up until here. They want us to calculate the area. So we're going to work on this area and that area. Okay? Let's see it now. Okay. So we're going to say that dA is equal to length times breadth. Then we're going to say that dA is equal to y times dx. So dA is equal to y dx. When you introduce your integral sign, you're going to end up with a equal to the integral of y dx. It's sort of like a standard thing, right? You're going to always have the whole first portion first, and you must have that because they give you a mark for that still, right? Then, this is not in terms of x, so we can't integrate that with respect to x. But the equation it's equal to is with respect to x. So, you are integrating cos 2x dx. That's the area we are looking at. Right? Now let's look at what we are integrating. We are integrating this portion plus this portion. So we're going to have to integrate here and work out the area and add it to this value to get the total area. Do you all agree with me?
Yeah.
So for this first portion, we're integrating from 0 to pi over 4. Yes?
Yes.
Right. So we're integrating from 0 to pi over 4. Plus, we're going to integrate from pi over 4 until pi over 2 cos 2x dx. Understand that? But what can we see about this? What can you tell me about it? It's going to become negative. We can see it because where is it? It's under the x-axis. So you know you're going to end up with a negative value. So what you do, you take the absolute value of that. Still with me? Now we integrate this. Yes? Okay. So what's the integral of cos 2x?
Sin 2x over
2. Because remember this is cos kx, not cos of x. Okay? This is cos kx. So cos kx, when you integrate it, it's cos kx over k. So this is sin, no, I mean sin kx over k. So this is sin 2x over 2 plus c, and you are integrating from 0 to pi over 4. Yes? Plus the absolute value of, and this is also going to integrate to the same thing, cos 2x, no, sin 2x over 2 plus c, integrating from pi over 4 to pi over 2. Before I carry, everybody with me on this. Now what do? You substitute your upper and your lower limits. So I'm going to write it from here. Okay? So for this first part, we're going to end up with sin 2 times pi over 4 all over 2 plus c minus sin of 2 times 0 over 2 plus c plus the absolute value of sin of 2 times pi over 2 all over 2 plus c minus sine of 2 times pi over 4 over 2 plus c. Absolute value. Right? What's that number? One over 2, right? So this here is 1 over 2 plus c, and here that is going to be 0. 0, right? It should be 0, the sign of 0 is 0. 0, right? Plus 0 minus c. Okay, c minus 0, right? Okay? Minus c. Plus the absolute value of, what's that? So it's 0 plus c minus a half minus c. Yeah. Okay. Yes? Anybody confused so far? Nobody's confused. So here, cancel, right? How does it look like chemistry now? Right? Half, because remember half minus 0 is half, right? Plus the absolute value of c and c will cancel, so it's the absolute value of minus half. But the absolute value of minus half is half. And you end up with 1 unit. Anybody confused what it is? You'll understand it, right?
Yeah.
So not to take in at once, but this is easy for you, and you've got this. Okay. So you're not getting the number. Yeah, you can say this is radians.
Radiant, yeah.
It is.
Yeah.
Which number you're not getting?
Just stop looking at everything.
Why do you do that? You did the same thing in just the sequence thing. See right? You're gonna put it sine of 2 times your calculation and the
Nothing like
yeah.
Oh, that's
So it might be sine of 2 times that would be just right? So because remember, if you don't put it in degrees, pi is taken as 3,14.
Oh, okay.
And then
Okay.
so your calculation must be in radians when you're working with pi. That's still a calculation. And try to don't forget the fractions, don't forget the brackets, the signs.
Yeah, I got it.
Okay? This is probably similar to one they could ask you in the exam. And guys, guess what? That brings us to the end of Mathematics N4. You all have done. Okay, so if you turn the page there, okay, so that's the end of integration. If you turn the page, it gives you a module summary. We never looked at module 1, so on page 270, where we looked at, well, you looked at determinants, right? You know second order determinants, you know Cramer's rule, you know how to do third order determinants, right? You did Complex numbers, you all know powers of I, you all know on page 271. Rectangular form, polar to rectangular, multiplication of complex numbers. Remember I told you for complex numbers that it's easier to add and subtract rectangular forms, and it's easier to multiply and divide polar forms. Okay, because remember when you adding and subtracting rectangular forms, you add the imaginary and you add the real parts, right? Yes?
Yeah.
When you doing polar forms, you divide the when you multiply your real parts and you add the angles, right? With rectangular forms it's different because you have to use your FOIL method where you multiply into the bracket and stuff. Okay, so just remember that, right? We did SIG. Okay, SIG is from where I came, right? So you have got your sheet that has all your rules, right? You'll know SIG. You've done it, you'll know it. SOHCAHTOA, you'll know. Okay, so what we did SIG? We did SOHCAHTOA, we did the triangles, the special triangles. We've done somebody else. We've done.
Okay, check.
Yeah. So we did we did the class diagram.
Yeah.
We've done trig identities. We've done double angles, compound angles, half angles, co-ratios, all of that. Yes? Thanks. Then we went on to graphs. So in graphs, we did sketching graphs. We know what's a domain. You know what's a range. You know what's a dependent and an independent variable. You know what's a function. You know what's a relation. What's a relation?
Yeah.
Right? Exactly. So they can ask you that in your graph questions. So most of the time they'll ask you for, you know that sideways parabola? When that one is x is equal to y squared, right? And you draw the parabola but sideways. It looks like a C.
Yes.
There, that's the relation, because if you take one value of x, you get a y value going up and the y value coming
Yeah.
down. Okay? So you get two values of y. You all know inverse functions. What you do, you swap your x and y and you basically solve for y again. You make the subject of the formula y. Right? You all know continuous and discontinuous functions. You all have done rectangular, hyperbolas, straight lines, circles, ellipse, hyperbola, half a circle, log and exponential graphs. You have done parabola. You have done cos graphs, sine graphs, tan graphs, everything you have done, right? Then we went on to differentiation, and you learned about limits. And you'll know limits in the form of 0 over 0. You'll know limits in the form of infinity over infinity, right? You'll know you know binomial theorem. You'll know differentiation from first principles. You'll know differentiation using the rules, the shorter method with just the rules. You'll know chain rule, product rule, quotient rule, how to work out maximum and minimum values, how to distinguish which is your maximum and minimum turning points. You'll know how to work out point of inflection. You'll know how to draw cubic functions. Yes? And now you'll know how to integrate the inverse of derivatives. And you'll know how to calculate the areas of a curve or under a curve using integration. Done a hell of a lot in 2 months, huh? Hey man, when you started, yeah. Are you anything?
No.
Is it not bad? Hey, after the recording.